This is my last video of the day for Unit 1. We're going to take a look at inverse functions. We're going to look at it algebraically rather than graphically or by sets. The sets are pretty straightforward. Basically, inverse in a very simple definition is you're just swapping out your x and y's. You've dealt with inverses before. Basically, just doing things opposite. So, real quick, what we're going to do here is find the inverse function of negative 2x minus 7 g of x. So we're going to do, we're going to substitute for y. And there's other ways to do this. I can swap out my x's and y's right off the bat. I can do x is equal to negative 2y minus 7 and solve for y. Or I can solve for x and then solve for y. It doesn't matter. Your book tends to solve for x, then do the swapping at the end. So we'll do it that way. So I have y plus 7 is equal to negative 2x. And I'm going to do the inverse. I'm going to divide by negative 2. So I have y plus 7 over negative 2. That's not a very good y is equal to x. Now this is just a rewriting of this. I've done nothing special. My inverse is the swapping out. Swap your coordinates, swap all your x's, all your y's. So we have my g of negative 1x is equal to x plus 7 over negative 2. Now we have an algebraic check that we can do. The algebraic check is just straightforward. We're going to do, again, it doesn't matter which way you can do. I could do g of negative 1 of x, or I can do g of negative 1 of g of x. These are little composite functions. It doesn't matter which way I go. I'm just going to put this right in here. So I have negative 2. And I wrote this fraction on purpose because I'm a little bit on the lazy side. X plus 7 over negative 2 minus 7. Of course these cancel out. That's why I did it. Boom, boom. All right. And now I just have x plus 7 minus 7 is equal to x. When you get back to x, you basically undid everything. You went back to its basic term, and you have yourself an inverse. So this is all well and good. Same thing here. We can have, I'm going to go ahead and do it the way I did it in other classes when I taught Algebra 1. So it's a little bit different than your book. I have y is equal to negative 1/2 x plus 3. And I went ahead and swapped right away. And I solved for y. So I have x minus 3 is equal to negative 1/2 y. I'm going to multiply by negative 2. So I have negative 2, and I'm going to go ahead and keep it in parentheses. I will not distribute, is equal to y. Okay? Now we're going to double check, so we can do h of h to negative 1 of x. All right? And I'm going to take this and put it right in here. So I have negative 1/2 times negative 2, hence I'll go and put this in brackets, and x minus 3. Okay? And plus 3. Okay, that's going to cancel out. Again, that's why I did it that way. That just cancels out. And I have x minus 3 plus 3 is equal to x. There you go. And we can check to see if they're functions, and we may have to restrict domains and things like that. But we just took two linears and did a real quick, short example. I'm going to go ahead and do a quadratic. Here we go. This is going to get quite different. This may exceed our 5-minute limit, but let's see what happens. So what I'm going to do is I'm going to have y is equal to x squared minus 8x plus 12. I can go ahead and swap out the x's and y's if I wanted to right now. But what I think I'm going to do is I'm just going to go ahead and solve this via completing the square. X squared minus 8x. I might as well go ahead and add in my 16 on both sides. So I have y plus 4 is equal to x squared minus 8x plus 16. Now I'm going to, that's a perfect square trinomial, that's why I did it. So I'm going to have, I'm going to flip them back and forth. Well, I'll just keep it like this. So I have y plus 4 is equal to x minus 4 squared. And I'm just solving the way I would normally do it. So I'm going to take the inverse, I'm going to take square root on both sides. So I have x minus 4 is equal to plus or minus the square root of y plus 4. Get rid of that 4 right there. I have x is equal to 4 plus or minus square root of y plus 4. So my inverse function well, I got to swap out, is this right here, is equal to 4 plus or minus x plus 4. Okay, and I can do the exact same thing by substituting in, but because I exceeded my 5 minutes, I will hold off on that. I'm going to get this posted to YouTube. See ya.